In the last problem, our graph of y equals log base 2 of x looked more or less like this, right? X equals 0. The y-axis was the asymptote. And this is what your graph will look like if you have y equals log base a of x. And a is bigger than 1. So that's what's going to produce a graph like this. So a in the last example was 2. Y equals log base 2 of x. It might increase a little less quickly or a little faster depending on the value of a. And then it turns out it gets flipped around and it'll look like this. The y-axis will still be an asymptote. It'll still go through 1, 0. But it'll get flipped around if a is between 0 and 1. So this would be the graph of y equals log base a of x if a is between 0 and 1. And if you don't believe that, try graphing log base 1/2 of x. Y equals log base 1/2 of x. Convert to exponential form. You'll see very quickly that that's the case. Either way, the domain remains the same. Sounds like a Led Zeppelin song. The song remains the same, right? Anyway, you guys probably don't know who Led Zeppelin is. Little before your time. No, you guys do, right? Yeah. They had 1 or 2 good songs. So, what? Remember, domain, the set of all input values, right? So look at both graphs, or one of the graphs. It doesn't matter. The domain's the same. Okay, left to right, what does it almost get to? It almost gets to the y-axis, which is x equals 0. So in interval notation, the domain is, well, almost 0 because it never quite gets there. So what symbol do I use? And then how far to the right can it go? It goes up and to the right all the way, whatever that means. It goes to infinity, right? Left to the right, it goes to infinity. What about the range? Think low to high. In either graph, how low does it get? How high does it get? It goes all the way down and all the way up, negative infinity to infinity. Guess what? That's the exact reverse of the domain and range for the exponential function f of x equals a to the x. Remember? That makes sense. Why? Because when you look at inverse functions, the domain and range are flip-flopped. That's the technical mathematical phrase we developed the other day. They're flip-flopped.